Hello, my name is Cornejo, and this is lab activity number 3 for class EEE3303 Lab. Start off with the active low pass filter. Resistors are 1 and over 2 are both 340 ohms, made from 133 ohm resistor, 110 ohm resistor, and the capacitor value shows them to be 0.047 microfarads. And here's the capacitor, there's a resistor right behind it. Kind of hard to see, but it's there. Voltage input was 1 volt peak to peak. The frequency in this case, in this graph, is 10 hertz output. They're both at 1 volt peak to peak. The only difference being the peaks are inverted. And this is a 10 kilohertz frequency right here, with the input still being 1 volt peak to peak, but the output is 0.708 volts. Around there, yeah. Here's a multi-sim lab simulation. And here's a board analyzer. It's very close. You can see here that it shows the frequency cut off to be 9.971 kilohertz, negative 3 decibels. Here is the actual measure board analyzer. Zoom out a bit. Gain is 0.72 at 10,000 hertz. And here we have a graph comparing voltage input to output with the gain, and for the most part they remain at close to 0.98 until I guess 5 kilohertz it gets lower, until 10 kilohertz that's 0.7106, and then it drops off because of the filtering. The gain calculation is 1, and the theoretical cutoff frequency is 9.996 kilohertz, which we agree with, the measurements agree with. This is the active high pass filter. Resistor R1 is 500 ohms, made from 1 420 ohm resistor and 310 ohm resistor. Resistor 2 is 1 kilo ohm, and the capacitor value is 0.1 microfarads. See right there, here are all the resistor series, capacitor, and then the feedback resistor. Okay, the voltage input was again 1 volt peak. This was a 1 kilohertz output measurement in the oscilloscope. The output was around 0.589 volts. And here we have it again. The output in this case is 1.681 volts. So the 5 kilohertz output. Then at 10 kilohertz output, it's a 1.909 volt output. Here is the multi-sim simulation, multi-level simulation. And you can see here, negative 3 decibels is 1.202 kilohertz. So that's, we should expect our frequency cutoff to be around that range. Here's what we measure with the actual circuit. Shows to be around 1.3 kilohertz, gain of 0.78. This is again graph comparing voltage input to output with the gain. So it starts off very low, and it just increases as the frequency increases, and from here there's a big change from almost 0.6 gain to 1.68, and that's because our frequency cutoff is 1.591 kilohertz, so somewhere between these two it reaches a 0.707 gain. And you can see here's the theoretical calculation. Give gain is 2. Now the active band pass filter, R1 is 100 ohms, R2 is 1 kilo ohm, capacitor 1 is 33 microfarads, capacitor 2 is 0.1 microfarad, voltage input was chosen to be 1 volt peak to peak. And here is the circuit. I got it here as well live. As you can see, at 50 hertz output is 7.082 volts at 50 hertz. That's supposed to be 500 hertz, not 500 ohms. But it's 9.347 volts. Yep, and then it decreases again to 2.9. Well, it is even lower at 5 hertz, 2.936. And here's the bow plotter of the multisim. You can see the resembles a band pass, what we expect the band pass frequency filter to be. Here's the actual one from our circuit, and it looks similar to the simulation. As you can see here, the voltage gain goes up, then it decreases, and our gain, which is calculated to be 10, which is, we can see the closest value here at 500 hertz. You can see the frequency cutoff for the high pass is 48.23, which is close. We got here closer to the 50, 7.07 gain. And here, a low pass cutoff, that means it's going to block off whatever is after it. It's 1.591, so once again, it's between here. You can see at 1 kilohertz, 8.192, so expect the 1.15 kilohertz to be the similar value, 7.07. And that's it for the lab. It's a long explanation because there were various parts to it. Bye.